Okay, so this is instrumentation, the frequently asked questions. Question 1, draw symbols for the following electronic components. Fuse, number 1, relay, indicator lamp, photodiode, dry dependent resistor. Try to pause the video and try to answer. Okay. Have you tried? Okay, so let's see how we can go about it. Okay, so the fuse, to draw the fuse, it's more like a box. Okay, so you just need to pay attention to details and then a straight line. Okay, and then we have, the use of a fuse. It prevents the what? Electronic shock, electronic damage, right? Or prevent, like damage to the electrical appliances. Okay. So it protects even us, when you're using something with, for example, the short circuit occurs, so it protects because this one bends out and then it prevents further damage to the electrical appliances. And then we have a relay. Okay, so a relay acts as an electromagnetic switch. Okay, it is used in industries for different purposes. And one of them is it acts as an electromagnetic switch. So here you have the switches. It's more like the switch. It may be connected or it may be open like this. And then you have something like an inductor. Okay. This is the simplest way of illustrating a relay. Okay, so it's more like there are switches and then this inductor creates a magnetic field, right? Yeah, so like that. So automatic switch or electromagnetic switch. And then we have an indicator lamp. You draw a circle and then you cross inside. Okay, very simple, right? What about a photodiode? A photodiode, just draw it more like a triangle facing this side or this side, okay? Most this side, and then you just draw like this, okay? As if something is going on and then coming out. And then you have the arrows more like the rays going towards the structure there. And this is how you draw the photodiode. Okay. And then you have light dependent resistor. You draw, it's more like a box, which looks like a fuse, but the line doesn't go beyond the box like that. And then you have got some of the arrows as rays. Okay, so this is light dependent resistor. Okay, so this is how you answer these questions. Okay, so let's look at other questions. Let's look at more questions. Okay, here we have more questions. Explain the energy changes performed by the following transducers. So transducers, they are just elements, okay, or parts of electrical appliances that changes from one energy to another. Okay, they are called transducers. Okay, any parts of the electrical appliances that changes from one energy to another. Okay, so here we have got a thermistor. A thermistor changes from electrical energy, because when electricity passes through the thermistor, it changes from electrical energy and then producing heat. So to what? Heat energy. Okay. And then we have got a what? Deuterium lamp. Deuterium lamp, it also used in atomic absorption spectrophotometer, even autocathode lamp. Okay. It is used in those machines whereby you need to determine the mineral content in form of a solution or just solid, whereby you just have to break down the electrons in a sample and to determine its concentration and its mineral content. So deuterium ramp, it's more like it's a ramp, okay, which is right, okay. So changes from electrical energy producing right, so to right energy. Okay. So what about hollow cathode ramp? So hollow cathode ramp also changes from electrical energy producing right to photon energy, right, which is right energy. Okay, so this one is also a ramp. So it may produce photon energy, okay, from electrical energy. Okay, so this is how it is. Okay, can you try now the question? So how does the energy change in a pH electrode and photodiode? So can you try and let me know once you get it right. So here, number one, AAS stand for atomic absorption spectrophotometer. Okay, it is about spectrophotometry, absorbing heat from the spectrum, right? Okay, so AES, it's atomic emission. So atomic emission spectrophotometer or spectrophotometry, it's about atomic emission, okay? And then number three, AFS, it's about atomic fluorescence spectrophotometer. Okay, so the only task you are going to do is just to try to know what the following does. Okay, these are the laboratory machines for different purposes. Okay, similar but different purposes. Okay, so this is what we have. These are the electronic symbols. Okay, so these elements are all electronic components. Okay, so the questions, okay, the questions are, I'm just going to ask the question. So the question is like, identify components that can convert electric current to write. Okay, so electric current to write. Which component? Okay, we have to identify the component that can convert electric current to write. Have you tried the component electric current to write? That is what? A light bulb. Okay, this is a light bulb. So it converts electric current to light. Okay. So what about component that can convert electric signal to sound? Do we have it? Yes, we have it. Where is it? Here we have it. It's a speaker. Okay. See, a speaker. So this one converts electric current to light. This one converts electric current to sound. Okay, to sound. Electric signal to sound, and then so the speaker converts electrical signal to sound. And then we have identify component that can convert electric current to identify the electric component that can convert electric current to kinetic energy. Identify component that can convert electric current to kinetic energy. Do we have it? Kinetic energy. From electric current to kinetic energy. You know, kinetic energy is the type of energy possessed by an object in motion. Do you have it? Yes. It's what? A motor. So you just have to know the symbols, okay? It's very important to know the symbols. So it's very important that you know what each of the following does. Okay. So what about, can you try these other questions? Let me know in the comments. Identify component that can correct stray currents in an electrical installation. That can correct stray currents in an electrical installation. The other one is identify component that can work as an operation amplifier. Okay, once you solve, let me know. Then I'll see if it's correct or wrong. So that is the work. The other work, you have to identify each of the following elements and know the symbol and what it does. Okay, for example, we have this component, which is what? PNP, PNP, okay? This is PNP type, okay? So PNP, positive, negative, positive. This is PNP, okay? So PNP type of transistor. Why PNP? Positive, negative, positive. So negative, okay. Why is it positive, negative, positive? Okay. Sorry, this is negative, positive, negative, okay. Negative, positive, negative, okay. Why is it like that? Because here the arrow is pointing outward, okay. So it will become negative, positive, negative, okay. And then if the arrow is pointing inwards, like this one, then it will be different. It will become positive, negative, positive. So positive, negative, positive. Okay, that's how it is. A transistor. Okay, so a transistor and it has two types. Okay, though there may be bipolar junction transistor as well, but this is what we need to know. Okay. So you can identify the lists, okay.